Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll describe examining interaction in regression in more detail. So at this point, we've been working with the pain data and we have looked at the results from the regression, and we've seen that the omnibus F is significant and that the interaction coefficient, the test for that coefficient, is also significant. So this indicates to us that the slope of the pain severity regression lines differs for males and for females. But just looking at the interaction coefficient, we can't necessarily tell how it differs. So we need to construct two separate regression lines for each of the groups in the moderating variable. These specific regression lines for each group are called simple slopes. So essentially, when we're talking about the individual slope for male and for female, those are the slopes indicating simple effects. So simple slopes, simple effects. This is basically the process of model testing for an overall regression with interactions. So the first thing that we do is we test the interaction. That's where we look at the significance test for the interaction coefficient. And if that is not significant, then we just examine the main effects only. That means we just look at the two variables and not their interaction. But if the interaction is significant, we then need to construct these simple slopes. And so we construct a simple slope for each group within the grouping variable. So in this case, there's just two, so we will only have a slope for group 1 and a slope for group 2. And we do this by creating regression equations for each of those groups. So remember when we looked at the scatter plot in the previous lecture, and we have the scatter plots separated out for males and for females, and there's a regression line for males and a regression line for females. These are actually the simple slopes. They're represented here on this plot. And in class, I'll show you how to get these lines on this plot. So now we can look at the equations and talk about how to construct these simple slopes. So to get the simple intercept and slope for males, we substitute in a value of 0 into the sex demicode where the sex demicode appears in the equation. And the reason we do this is because we have males coded as 0. So we're just simply subbing in the value for male, which is 0, wherever we find the sex demicode in the equation. So in the top equation, we see that sex, the demicode, occurs within the brackets next to B3, and then we also have the B2 coefficient, which is the main effect of sex on stress. So to get the male intercept and slope, the regression equation for just males, we substitute in sex equals 0. And so this cancels out the B3 coefficient and the B2 coefficient. And this actually reduces our equation to be B0 plus B1 times pain severity plus some error for the overall regression equation. And so this gives us 12.751, which was the overall intercept for the model, plus 0.144, which was the B1 coefficient relating pain severity to stress. And this is what we would use to construct the simple slope. So in the SPSS output, we can actually find these values. This is where we find these values. So anytime we are constructing a simple slope for a group coded 0, it's just the overall intercept coefficient and then the focal predictor slope. And then when we construct the simple slope for females, we're going to do the same thing, but we're going to substitute in a value of 1 because that's how we have females coded. And so now we're not reducing the equations. We actually are going to be multiplying the B3 coefficient by 1 and the B2 coefficient by 1. And so in the second equation, I've showed those substituted values of 1. And then I've taken them out and sort of rearranged the equation a little bit in that third equation. So because we have B0 and B2, as coefficients that have no variable attached to them, I've grouped them together because we're just going to be adding those values from the output. And then we're going to be adding together the B1 and B3 coefficient values, and those are going to be relating to pain. And so that grouping with the actual values plugged in from the output is shown in the fourth equation here. And then I've just simply summed the values and reduced that equation for the bottom equation. So we can see that the stress slope for females differs from the slope for males. So the slope for males was simply the intercept and the pain slope. And so it was 12.751 plus 0.144 times pain. But now we can see that the intercept for females is higher than that. It's 15.383 because we've had to add the B2 coefficient to the intercept. And then we see that the pain coefficient is 0.534 because we've had to add the B3 coefficient to pain. So that is essentially the slope relating pain severity to stress. And it's higher for females than for males, which is what we would expect to see. So because we are summing these four coefficients, the B0 and the B2, and then the B1 and the B3, we can actually get these values from the output as well to get the simple slope for females. So let's take a look at that. So for the intercept and slope for males, because they were coded 0, that was simply the intercept, the regular intercept, and then the centered pain severity slope, which I had already highlighted on the previous slide. But now we can use the unstandardized coefficients for sex and for the interaction. But now these are the difference in the intercept and the slope for when the moderator is equal to 1, so for the females group. So the intercept is the regular intercept plus the sex coefficient, and then the slope is the centered pain severity slope plus the interaction. So I've showed you how to calculate these equations, and now let's look at how they map on to the simple slope plot. So this actually makes sense because we have pain centered. So looking at a score at the very center of the plot is where pain is a score of 0 because it's centered. And so that is where we're going to find the constant. It's going to correspond to stress. So if we look at that center of the plot, we can see that the simple slope for females crosses pain equals 0 when stress is equal to a little bit above 15. This makes sense. And then the slope for pain is more positive. And then if we look at the male simple slope, we can see that where centered pain is equal to 0, it crosses that 0 point when stress is equal to just above 12.5. And then also we can see that the pain slope is a little bit smaller for this line. And so the line is a little bit flatter. So our interpretations, now that we've examined the interaction a little bit further, we would say that the overall interaction is significant, and the female slope is more than 3 times larger than the male slope. Now, remember, we're just talking about simple slopes, so the slopes are in the exact same units. So we, in fact, can say that the female slope is more than 3 times larger than the male slope because we're directly comparing units. We would also say that kind of overall, that higher pain severity scores are associated with higher stress levels, but that this association is stronger for females than for males because we see that their slope is higher, indicating that the relation between pain severity and stress is stronger for that group. This concludes the third lecture on moderation and regression with interactions. And in the next lecture, I'll describe an example of an interaction with a continuous moderator.